Welcome to Master Concepts in Chemistry. In this lesson, what we're going to do is we want to calculate the volume of an object when the mass and density of the object are known. Okay, so let's go ahead and read the problem. So the problem says determine the volume of an object that has a mass of 455.6 grams and a density of 19.3 grams per cubic centimeters. Okay, so density has units of grams per cubic centimeters. So grams per cubic centimeters. So that is our density. So we want to find our volume. Okay. So the first thing you need to recall is the density formula. So we write D equal to M over V. Okay. So here we want to find V because we know mass and we know density. Okay. So we can isolate our V. So what we need to do is we cross multiply and then isolate our V. So remember D is on top, D is a numerator, so below it is a denominator, which is 1. So we cross multiply. So T1 times N will give us M, and then D times V will give us dV. But we want V, so we divide here by D, divide here by D. So D cancels D. So our V is equal to our mass over our density. So we plug in our values. So our mass is 455.6 grams. And our density is 19.3 grams per cubic centimeters. So remember when they say per, that means divided by something. So grams divided by cubic centimeters. Okay. So as you've seen, once you divide grams by cubic centimeters, the cubic centimeters is going to be at the bottom. So the grams here will cancel grams. And then the cubic centimeters will move up. Okay, so basically, what we're going to get 455.6 over 19.3, and then the cubic centimeters will be on top, like that. Okay, so yeah, so like that. So once we divide our 455.6 by 19.3, our answer should be 23.606 cubic centimeters. Okay, but here again, you have to report your answer to the correct number of significant figures. So you've seen that the top number, which is our mass, has 4 significant figures. 1, 2, 3, 4. 4 significant figures. And our bottom, which is density, has 3 significant figures. 1, 2, 3. So that means that the mass is much more precise than the density. So our final answer for volume should reflect the least number of significant figures, which of course is the density value, which is 3 significant figures. So we can rewrite this as 23.6 cubic centimeters because our third significant figure ends at 6, but the number after 6 is 0, so we can't round 0 up because it's less than 5, so we just round down. So our answer is 23.6 cubic centimeters. So that is our volume. Okay, so I just want to point out something. Sometimes when students are dividing mass by density, the units always confuse them. So basically, I want to rewrite the calculation in this form. So we can say 455.6 grams divided by 19.3 grams divided by cubic centimeters. Okay. So remember, it's grams per cubic centimeter. So we can flip the grams per cubic centimeter so that we'll have something like this because we are dividing. So we'll have 455.6 grams over 19.3 times cubic centimeters over 1 grams. So grams will still cancel grams. So you just have cubic centimeters left. So you see, so you have 2 units in your density, grams divided by cubic centimeters. And you still have the division line, the big one, which is 455.6 grams divided by 19.3 grams per cubic centimeter. So you have to, the cubic centimeters will move up, okay, like we have here. So another way of doing that is multiplying your 455.6 grams over 19.3 times your cubic centimeters per gram. So you flip the unit of your density to get that. Okay, so once you follow through, your answer should still be the same as what we got. If you run it to the correct number of significant figures, you should get 23.6 cubic centimeters. Okay, so that is that. So that is using the density formula to arrive at our volume. So another way of doing this is we can set up a table and then use the mass given and also the density given and then calculate our volume. Okay, so let's go ahead and do it. Okay, so as you've seen in the question, you have been given density. We know our density, which is a drive unit, grams per cubic centimeter. We also know our mass, which is grams. So our mass just has one unit, which is gram, but our density is a drive unit. So what we'll do is we'll draw a table. Okay, and this side we'll write the unit, one of the units given, the one that is just standing with one unit, which is mass. So here we'll write our mass. So our mass will be the 455.6 grams. Okay, and what do we want? This side we'll write what we want. We want our volume in cubic centimeters, so we'll write cubic centimeters. So at the bottom here, what do we write? We write the unit we don't want at the end, the unit that needs to cancel out, and that unit is a gram, so we'll write grams here. Okay, so as you've seen, this is our density flipped, cubic centimeters and then grams. So our density value flipped. So our density is 19.3 grams per cubic centimeter. So another way of writing this number is to say 19.3 grams over 1 cubic centimeter. So as you can see, 1 goes with cubic centimeters and 19.3 goes with grams. So since we have grams here, we'll put 19.3 here, and then 1 goes with cubic centimeters, so we'll put 1 here. So you see that, then we'll close our table. So we then proceed to solve. Okay, so the units on the diagonal always cancel. So this will cancel that. And we are dividing basically 455.6 by 19.3, which is similar to what we had earlier. So our answer will be 23 So our answer will be 23.6 cubic centimeters, like we had before, because we're dividing 455.6 by 19.3, which is similar to what we had earlier. So what I was saying is that one way of solving such problems is to always remember that your density is a conversion factor. So you can always set up a table like this. Start off with one of those that is known with 1 unit attached to the number, so which is grams, and then you then set up your density ratio using the right form to help you calculate what you want. So because we want volume cubic centimeters, we have to flip our density so that the grams will cancel out the grams and we just have cubic centimeters. Okay, yeah, so likewise, if we want a mass, yeah, we'll flip this ratio again, and then we'll set it up and then have our mass value calculated as a result of it. Okay, so what I'm trying to say is that once you have your density value, you can always write 2 ratios. So our first ratio with our density value, which is 19.3 grams per cubic centimeter. So our first ratio, which is our first conversion factor here, is 19.3 grams over cubic centimeters. And our second conversion factor, which I call B, is 1 cubic centimeters over 19.3 grams. So you see the conversion factors? So remember, 1 is always with your unit. If no number is attached, 1 is always implied. Okay, so yeah, so like that. So the ratio that we use to figure out our volume was this one. Okay, so you see that 1 over 19.3. Okay. So that is how to calculate the volume of an object when the mass and density are given. Okay, so thanks for watching.